Hi everyone, today we're going to study graphs of linear functions. First, let us define linear functions. A linear function is a function whose graph is a line. Linear functions can be written in the slope-intercept form of a line. This is f of x equals mx plus b. We know that m, the coefficient of x, is the slope of the line, and the b is the y-intercept. Showing the ordered pair, we can write 0, b. As defined, y-intercept is the point where the graph intersects the y-axis. Also, there is x-intercept, and that is the point where the graph intersects the x-axis. To illustrate, we have here a line, and with respect to the rectangular coordinate system, this point here is the y-intercept, while this point is the x-intercept. To find the x-intercept, we set a function equal to 0 and solve for the value of x. So given f of x equals 0, we can have mx plus b equals 0, and this positive b is transposed on the right. The sign is changed, so we have mx equals negative b. Since we want to get x alone on the left side, we will divide this equation by m. So the m here will be cancelled out, only x comes down, and this is equal to the negative b over m. So the x-intercept equals negative b over m. We may use this formula to get the x-intercept. To summarize, the general form of the linear functions is f of x equals mx plus b. The y-intercept, we may write the ordered pair 0 and b. For x-intercept, it has the ordered pair with x-coordinate negative b over m. Take note, this b is that y-intercept over the m, which is the slope of the line. Then comma, 0. How to graph a linear function? We are going to follow two steps. Step 1, find the intercepts. Step 2, draw the line connecting the intercepts. Let's have examples. Find the slope and intercepts, and then sketch the graph of the linear functions given below. Number 1, f of x equals 3x minus 6. So we write the general form of the linear functions here. The f of x equals mx plus b. First, we can collect the slope, which is the coefficient of x, and that is 3. Followed by the y-intercept, which is the negative 6. And if we write this in the ordered pair, it will be 0, negative 6. For the x-intercept, we're going to use this formula, negative b over m. Substituting the values, this is equal to, first, the b is negative 6 over the m is 3. And then this negative and negative becomes positive, and 6 divided by 3 is equal to 2. To show this as an ordered pair, we will write 2, 0. Now let us sketch the graph. Let us show the x and y axis and then identify the negative 6 in the y-axis and the positive 2 in the x-axis. Then let us plot the points. First is 0, negative 6, that is the point, followed by the 2, 0, that is the point. And then we will connect the 2 points, and this is now the line f of x equals 3x minus 6. This is our final answer. Let us have example 2. Let us find the slope and intercepts and sketch the graph of this f of x equals 4 minus 2x. The general form of linear functions is written here. For our convenience, we may rewrite this problem in such a way that the negative 2x comes first. And from here, we will collect now first the slope, and that is the coefficient of the x, which is negative 2. Next is the y-intercept with coordinates 0, 4. You can see I copy directly the constant in the function, and it is written here. Next is the x-intercept. We will follow the formula negative b over m. And substituting the values, this is equal to negative 4, that is the b, over the negative 2, which is the slope. And then we simplify. Negative and negative becomes positive. 4 divided by 2 is equal to 2. Showing now the ordered pair of x-intercept, we have 2, 0. To sketch the graph, let us first show the x and y axis, and then let us identify the 4 in the y-axis and the 2 in the x-axis. Then let us draw first the y-intercept, that is the point, and the x-intercept 2, 0, that is the point. And then we simply connect these 2 points, and this is now the line of the function 4 minus 2x. This is our final answer. 1/2 x minus 3. We write the linear form here. F of x equals mx plus b. Let's begin now with finding the slope. The slope is the m. In our linear form, m is the coefficient of x. For this equation, the coefficient of x here is 1/2. That is the m. So we write here 1/2. Now, let's begin with finding the y-intercept. The b here is the y-intercept. The value is negative 3. But we're going to write here as a point. So, we have the x-coordinate to be 0, and the y-coordinate is that negative 3. This is the point y-intercept. What about x-intercept? We will follow this formula. Negative b over m. The b is this value negative 3, while the m is the 1/2. So we substitute it here. So we have negative of negative 3 all over 1/2. Let us simplify. Negative and negative becomes positive. So then we copy the 3 times this 1/2, we flip as 2 over 1. Then we multiply 3 by 2, 6, divide by 1 is 6. then we write this value 6 as a point, and that will be 6 as the x coordinate and the y coordinate is 0. Now we have the intercepts, the y-intercept and x-intercept. Let us plot the 2 points in our xy axis. This is the point 6, 0, and this is the point 0, negative 3. We'll just connect these 2 points by a line. This is now the sketch of the graph of this linear function. Example 4, negative x plus 2y equals 6. Let us isolate here the y. That means negative x we transpose to the right. The negative x becomes positive. So we have now 2y equals x plus 6. Then we divide this equation by the coefficient of y, which is 2. If we do that, this coefficient 2 will come as denominator of the right side. So we have y equals x plus 6 all over 2. We distribute these 2 to the x and to the 6 respectively. So the right side becomes x over 2 plus 6 over 2. We can rewrite our right side. This x over 2 we can write as 1/2 times x, and then the 6 over 2 we write as 3. So we have 1/2 x plus 3. This is our linear function standard form. Remember that the y here is the same with f of x. Now we can collect for the m or the slope and the b, which is the y-intercept. Let's begin with the slope. That is the m. This is the coefficient of x, and that is 1/2. This y-intercept is the b. So we write here 3. Showing this as a point, we write 0, 3. Remember that for y-intercept, the x-coordinate is 0. Now we proceed to x-intercept. Our formula, negative b over m. Let us substitute the values. So we have negative of b, that is 3, all over the m, that is 1/2. We simplify this as negative 3 times 2 over 1. Then finally, the value is negative 6. Showing this as a point, we write negative 6, 0. Remember that for x-intercept, the y value or the y coordinate must be 0. Now, let us plot the 2 points. This is now the point negative 6, 0, and this is the point 0, 3. We connect these 2 points by a line. And this is now the graph of this function. Today we're going to study graphs of quadratic functions. In particular, we will study the general form of quadratic functions. A quadratic function is a function of degree 2. The general form of a quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. By the way, when we say degree 2, the highest power that we can see in the function is square. Let's have examples. This is the first example. F of x equals x squared plus 4x plus 3. With regard to the general form, we can collect the values of a, b, and c respectively for the given function. So in here, the a is 1, that is the coefficient of x squared. The b is 4, and the c is 3. Another example is f of x equals negative 2x squared minus 4x plus 8. Also, the a equals negative 2, the b is negative 4, and the c is positive 8. This is now a fact that the graph of a quadratic function is a parabola. These are pictures of parabola. One is opening up, another parabola is opening down. Let's begin with a parabola that opens upward. The general form of the quadratic function is here. The f of x equals ax squared plus bx plus c. The properties are here. Number 1, a is greater than 0. It means the a, which is the coefficient of the x squared, is positive. We have the example a while ago. In here, the a is positive 1, and we can say that this function has a parabola that opens upward. Property number 2 is the vertex. This is the vertex, the lowest point of the parabola that opens upward. And the ordered pair of the vertex is hk. The formula for h equals negative b over 2a. Take note, the b here is the coefficient of x, while the a is the coefficient of the x squared. And the k value equals f of h. Property number 3, the axis of symmetry. A parabola has symmetry with respect to a line, and this line is called the axis of symmetry. We can see this is a dotted red line in here. And the formula for the axis of symmetry is x equals h. Property number 4. The domain is all real numbers, and we can write it in the interval notation to be negative infinity, comma, infinity. For the range, these are the values for the y. So this is square bracket k, comma, infinity. Number 6, the minimum value, which is k, equals f of h, or we can simply copy the value that we have from the vertex. We can write here. Number 7, decreasing interval. A parabola has a decreasing interval, and later on we will have increasing interval. If you're going to read the parabola from left going right, the decreasing interval is the left side of this parabola with respect to the line of symmetry. So we can write the interval to be negative infinity, comma, h. And we use the square bracket. Likewise, for the increasing interval, this is the graph, the right side of the parabola, that is the increasing interval. It is going up. And the interval notation for that is square bracket h, comma, infinity. Now let us have the parabola that opens downward. The vertex is now on top. And let's begin with our property number 1. A is less than 0. It means A is negative. A while ago, we have an example f of x equals negative 2x squared minus 4x plus 8. We can see here that the value A, the coefficient of x squared, is negative 2. We can say immediately that the graph of this function is a parabola that opens downward. Let's go to property numbers 2, 3, 4. These three properties are the same properties of the parabola that opens upward a while ago. The vertex is hk, and we can compute the h equals negative b over 2a. Again, b is the coefficient of x, and the a is the coefficient of x squared. Also, the k equals f of h. Property number 3, the axis of symmetry, this is the axis, and the equation is x equals h. Property number 4, the domain is all real numbers, and the interval notation is negative infinity up to positive infinity. Property number 5 is the range, the values for y. So with respect to the y-axis, it starts with negative infinity, and the highest is the k value, and we use the square bracket. Number 6, the maximum value is k, and we can simply copy the value of k in the vertex. We can write here. Number 7, decreasing interval. So the interval from which the graph is going down. So our parabola is opening downward. So the right side from here, it is decreasing. So our interval notation, square bracket, h, comma, positive infinity. For number 8, the increasing interval is the left side of the parabola. It is going up. So our interval notation for the increasing interval is negative infinity, comma, h, and we use the square bracket. Let's have an example. Sketch the quadratic function f of x equals x squared plus 4x plus 3, and find the following: a. Vertex, b. Axis of symmetry, c. Range, d. Maximum or minimum value, e. Decreasing interval, f. Increasing interval. First, let us write the general form of the quadratic function. F of x equals ax squared plus bx plus c. And then, let us collect the corresponding values for a, b, and c in the given function. So a equals 1, b equals 4, and c equals 3. Please note that the a is positive, and we can say now that this parabola opens upward. Now let us start calculating the vertex. We have the formula for the vertex. For the h is equal to negative b over 2a. Let us substitute the values. For the b, it is 4, and for the a, it is 1. So let us simplify this negative of 4 over 2 times 1, and we have the answer negative 2. This is the h. Now for the k, what we will do, we will use this value of h in our original function. It means I'm going to copy the same function down here, but every time there is an x, I will change that by the h value, which is negative 2. So we have the x squared becomes the square of negative 2 plus 4x is now 4 times negative 2 plus 3. We simply copy here. Then we simplify. The square of negative 2 is positive 4 plus 4 times negative 2 is negative 8, and then plus 3. Simplifying this, we have the answer k equals negative 1. It means we will write the vertex as an ordered pair. It is negative 2, negative 1. We will copy this value opposite letter A in here. So we have now the answer for the vertex. Since we have the vertex, we can draw now the parabola. This is now our parabola, and the parabola opens up. Let us compute now for the axis of symmetry. This line here. We have the formula, and this h is simply the negative 2. So we will just replace this h by the negative 2. So we have now x equals negative 2. And this is now the axis of symmetry. For the range, the formula is square bracket k, comma, infinity. This k is the y coordinate of the vertex. So we will just change the k by negative 1. So our range is square bracket negative 1, positive infinity, close parenthesis. So we are done with the range. Now letter D, maximum or minimum value. Since the parabola is opening upward, we have a minimum value. There is no maximum value because the parabola is going up continuously. So the minimum value is that k equals the f of h. No need to compute for this. The k value we can simply copy from the y coordinate of the vertex. So k equals negative 1. So we are done with letter D. Now for letter E, let's have the decreasing interval. The parabola is opening upward. The left side of the graph with respect to the symmetry is our decreasing interval. And our interval notation is negative infinity up to h. So we will just change this h by our x coordinate of the vertex. So we have negative infinity, comma, negative 2, square bracket. So we are done with decreasing interval. Going to increasing interval, that is now the right side of our parabola with respect to the line of symmetry. And the interval notation is square bracket h, comma, infinity, parenthesis. Now this h, again we will change by the value that is negative 2. So it becomes square bracket negative 2, comma, infinity, parenthesis. So this is now the answers for our example. Example 2. Sketch the quadratic function f of x equals negative 2x squared minus 4x plus 8 and find these 6 details. First, let us collect the values a, b, and c. A is the coefficient of x squared. We have here negative 2. B is the coefficient of x, so the value is negative 4. C is the constant 8. Note that A here is negative, so our graph is a parabola that opens downward. Here is a picture of a parabola that opens downward. Let's now begin finding the vertex. Vertex is the point HK. This is the highest point of the parabola that opens downward. Here is the point. Let us compute for the values h and k respectively. Beginning with h, the formula is negative b over 2a. b is negative 4, a is negative 2. So this is now the negative of negative 4 over 2 times negative 2. We simplify the denominator as negative 4, and finally the value is negative 1. This is the h. What about the k? K equals f of h. Our h is negative 1, so we evaluate f of negative 1. Our function is here, so we evaluate this by negative 1. So we have negative 2 times the square of negative 1 minus 4 times negative 1 plus 8. The square of negative 1 is positive 1. Negative 4 times negative 1 is positive 4, then plus 8. Negative 2 times 1 is negative 2, then plus 4, then plus 8. Finally, the answer is 10. This is our k. So the vertex is negative 1, 10. We write this answer opposite letter A. What about letter B? Axis of symmetry. Remember that axis of symmetry is the vertical line that passes through the vertex. And our formula is x equals h. Our h is negative 1. So the axis of symmetry is x equals negative 1. This is the answer for letter B. Then we go to letter C, the range. Range is the possible values for the y of the graph. Since the graph is going down, the highest value for y is this 10. So the range is from negative infinity up to 10. Then letter D, maximum or minimum value. Since the graph is going down, there is no minimum value because this is continuous. We have now maximum value. This is the highest value for the y, and that will be k equals 10. Next, E and F, decreasing interval and increasing interval. Let us read the graph from left to right. Our reference is the axis of symmetry. From the axis of symmetry going to the right, the graph is going down. So the right side is the decreasing interval. With regard to x, the decreasing interval is from negative 1 to positive infinity. What about the increasing interval? From the left side, going to the axis of symmetry, the graph is going up. So this is the increasing interval. With regard to x values, the increasing interval will be from negative infinity to negative 1. These are now the answers. Today we're going to study graphs of quadratic functions given the standard form of a quadratic function. Let us now identify quadratic function in standard form. The standard form of a quadratic function is f of x equals a times the quantity square of x minus h, then plus k. We know that the graph of a quadratic function is a parabola. In the standard form, we can see here the h and the k, and that is exactly the vertex of the parabola. Also, this a gives a very special idea. The parabola opens upward when this a is positive, or the parabola opens downward when this a is negative. Let's have an example. Sketch the graph of the function f of x equals -3 times the quantity square of x plus 2 plus 4, and find the following. Letter A, vertex. B, axis of symmetry. C, range. D, maximum or minimum value. E, decreasing interval, and F, increasing interval. From the standard form of the quadratic function, as written here, we can collect the vertex immediately. However, let us make sure that the given function must be in the standard form, or we may rewrite the given function into the same way with our standard form, and it will be like this. We are going to copy exactly the same except in this plus 2. Since the standard form is written minus h, we are going to rewrite this plus 2 into negative of -2, and the rest of the function will be same. And from here, we're going to collect now the vertex or the hk values. So this -2 is the h and the +4 is the k. Therefore, the vertex has the ordered pair -2, 4. And then this -3 is the a. And since our a here is negative, it means the parabola opens downward. So let us copy the vertex opposite this letter a, and we will take note that the parabola opens downward here. Then let us clear the right side of the screen. Since the vertex is known and we know that the parabola opens downward, we can now draw the parabola. So we have a parabola here that opens downward, and the vertex is the highest point. That is now the point -2, 4. Now letter B, for the axis of symmetry, it is the vertical line that passes through the vertex. And our formula is x equals h. And this h is the x coordinate of the vertex itself. So we will just substitute the value. So here the h becomes -2. Therefore, the axis of symmetry is x equals -2. For the range, we have the formula, the negative infinity, comma, k, and we use the square bracket. This k is the y-coordinate of the vertex. So we will just substitute the k. It becomes 4. The range now is negative infinity. Of course, we use the parentheses, then comma, 4, and the square bracket. Now for letter D, maximum or minimum value. The parabola opens downward, so we don't have a minimum value because the graph of parabola goes down continuously. So we have a maximum value here. And that value is equal to the k itself, and this k is that y-coordinate of the vertex. So we have k equals 4. So the maximum value is 4. Now letter E, decreasing interval. With respect to the axis of symmetry, the right side of the parabola is our decreasing interval. Do you remember? We're going to read the graph from left to right, and when it is going down, that is the decreasing interval. So this side here is the decreasing interval, and our formula is the square bracket h, comma, positive infinity, parenthesis. And this h we will now change by the x coordinate of the vertex. So the decreasing interval h becomes -2. So this is now our interval notation for the decreasing interval. For the increasing interval, that is the left side of our parabola. You see here, if you read the graph from left to right, so that is the increasing interval. And we have the formula for that. That is the parenthesis, negative infinity, comma, h, and square bracket. We will just substitute the h value with our x coordinate of the vertex. So our answer is the negative infinity up to -2. We use the square bracket here and also the parenthesis because we know every time there is infinity, always parenthesis is used. So we are now complete with our answers. Example 2. Sketch the graph of the function f of x equals the square of x minus 3 plus 2 and find the following. We have here 6 problems. First, let us copy our function here. Then let us write our standard form. And it is here now. First, let us collect the a value. We can see here that there is no number in front of this square of x minus 3. That means a here equals 1. And 1 is positive. Since a is positive, we say that the parabola opens upward. Now let us solve for the vertex. Using our formula here, the vertex is the point hk. Correspondingly, the hk is this 3 and this 2. So the vertex is 3, 2. Let's copy this answer opposite the vertex. Then we go to axis of symmetry. Axis of symmetry is a line. And the equation is x equals h. The value of our h here is 3. That means the answer is x equals 3. So we copy this answer in front of the axis of symmetry. Then we go to letter C. Before we put the range, let us try to figure out the parabola. It is opening upward. The vertex is the point 32, and the axis of symmetry is here, the line x equals 3. Now look at the range. Range means these are the possible values for the y. So it starts from here going up. So the range will be from 2, that is closed, up to positive infinity. That means going up. Then we go to letter D, maximum or minimum value. Since our parabola opens up, there is no maximum value because this is continuous. What we have here is the minimum value. Minimum value with respect to y. We can see that the lowest point here is the value of k equals 2. This is the answer. Now, letter E, decreasing interval. We can see that if we read this graph from left to right, from this point up to the value of x equals 3, the graph is going down. So, this is decreasing on this interval. So, the decreasing interval will be from negative infinity up to positive 3. And then, from 3, it goes up, going to the right side. That will be the increasing interval. So, we write from 3 up to positive. These are now the answers. Today we're going to study application of quadratic functions. Let us have this example. The quadratic function h of t equals negative 16t squared plus 176t plus 4 models the height of a volleyball hit straight upwards with velocity 176 feet per second from a height of 4 feet. Letter A. How many seconds will it take the volleyball to reach its maximum height? Letter B. Find the maximum height of the volleyball. Take note, our height denoted by h and the measurement is in feet, while time denoted by t is measured in seconds. Let us first copy our function, and it is now written here. And then let us collect the a, b, c. It means our a is the coefficient of the t squared, which is negative 16. The b is the coefficient of t, and that is 176. C is the constant, which is 4. So we have here a quadratic function with the value of a as negative 16. So we have here a parabola that opens downward. It means to say we have a maximum value. Here is a figure of a parabola that opens downward, and the highest point is what we call the vertex, and the k value is the maximum. And this line here is the axis of symmetry. Now, let us solve for a, and that is finding the time t. In here, we're going to use the equation of the axis of symmetry. And the formula is t equals negative of the fraction b over 2a. Substituting the values, we have the negative of b, which is 176, all over the constant 2, multiplied by a. And our a is negative 16. Let us simplify our denominator. 2 times negative 16 will give negative 32. This negative sign here and the negative of 32 will give positive, and the quotient 176 over 32 will give 5.5, and this is the time in seconds. Let us copy this value opposite problem A. So this is the answer for the problem A. Now, let us solve for problem B. In here, what we will do is to evaluate our function using the value of t that we solved from A. So this is h of 5.5. Let us now evaluate our function, and every time we have t variable, we will change by 5.5. So we have now negative 16 times the square of 5.5 plus 176t, and the t is now changed into 5.5. Then we copy this plus 4. Simplifying further, the square of 5.5, we will simplify that into 30.25. And then plus, we get the product of 176 and 5.5, and that is equal to 968. We simply copy the constant plus 4. Of course, in the first term here, the negative 16 is copied down here. In the next line, we will get the product of negative 16 and 30.25, and the answer is negative 484. So we copy the plus 968 plus 4. Simplifying these three numbers, we have now 488. And this is the height given in feet. Let us copy this opposite problem B. And this is our answer. Take note, the vertex of the quadratic function is 5.5, 488. This is our final answer. Example 2. A backyard farmer wants to enclose a rectangular space for a new garden within his fenced backyard. He purchased 80 feet of wire fencing to enclose 3 sides, and he will use a section of the backyard fence as the 4th side. We have here 2 problems. Let's begin with problem A. Find a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. First, let us illustrate our problem. So here it is. This is the backyard, and this is the garden as wanted by the farmer. Let this be the side L or length. Another length is here, and this is the side W. For condition 1, it says that length plus W plus length equals 80. This 80 is the length of the wire purchased by the farmer. Let us simplify this. L plus L is 2L plus W equals 80. Then we isolate W. This 2L we transpose to the right, so it becomes negative. So W equals 80 minus 2L. Let us note this equation on this side. Then we go to condition 2. The condition 2 is about the area of this rectangle. So that is A, that is the area, equals length times width, L times W. From here, we're going to substitute the value of W in terms of L to this area formula. So when we do that, A equals this L times W now becomes AT minus 2L. Then we multiply this L to the binomial. So L times AT is ATL. L times negative 2L is negative 2L squared. Let us rewrite this equation into standard form of quadratic functions. That means the higher power should come first. So it becomes like this. A equals negative 2L squared plus ATL. This is the answer in our problem A. Let us copy this answer somewhere here. Then we go to problem B. What dimensions should he make to maximize the enclosed area? Note that in our equation here, this quadratic has negative leading coefficient, that is the negative 2. So the graph or this parabola opens downward. Thus, the vertex will give the maximum value for the area. We know that vertex is a point, so vertex is the HK, the coordinates. Let us now solve the values of H and K respectively. So we start with the H. But before that, let's collect the values of the coefficients of this quadratic equation. So we have the A, which is negative 2. This is the coefficient of L squared. The B is AT. This is the coefficient of L. And the C, constant, it's not here, so we write 0. Now let us solve for H, and the formula is negative B over 2A. When we substitute the values, we have negative 80 all over 2 times negative 2. The denominator 2 times negative 2 is negative 4. Negative and negative becomes positive. So we divide 80 by 4. We have positive 20. This value is in feet. Actually, this value is the length. Looking at our figure here, this is the side L. Now, what about the K? The formula is the area formula with respect to L. Our L value is 20, so we have A of 20. We substitute this 20 to the L, so we have negative 2 times 20 squared plus 80 times 20. Then we simplify. 20 squared is 400 plus 80 times 20 is 1,600. This negative 2 times 400 is negative 800 added to 1,600, so we have 800. We can put the unit of measurement, square feet. Since this is A, that means this is the maximum area. So let us solve now for the W using this formula here. That is 80 minus 2L. Again, our L is 20, so we substitute it here. So we have 80 minus 2 times 20. 2 times 20 is 40. So 80 minus 40 is 40. This is in feet. This is the width. So we have the answers. 20 for L, 40 for W.